Firstly, big round of applause for all of you for taking time out on the weekend. I know it becomes very difficult to spend weekends learning something new. So really, thank you for coming over. Uh, Cool. So what we are going to learn today is about hosted agents. We'll talk about what they are. We'll try to cover some basics as well. What agents are. I'm not sure. I'll try to run that pulse check in a bit. How many of you might have created these agents using what tools, platforms, etc. And we'll also see the basics of the tech here today, because the intent here is to not overwhelm you with everything and less than 45 or 50 minutes. But then what matters here is the sort of business value that these services bring to the table. Because ultimately, when technology matures, it's all about how it is helping the business, how it is helping you run your operations and workflows efficiently, right? So we'll take a look at that as well. A quick introduction of me. My name is Bhushan Gawale. I work as a Chief AI Officer at Rapid Circle India. I am also a Microsoft MVP in AI platform, and I am a TOGAF and Azure certified architect as well. So with that introduction, let's dive into the bit of a basics here of agenda, what we would be taking a look at. Three things basically. At the end of this session, what I want to ensure is that each one of you should be able to go out of this room and then explain what hosted agents are to your team members in less than maybe 2 lines. Yeah, because that's the simplicity. Let's try to do that. So we'll have a clear mental model in terms of what hosted agents are, why they matter. So like I said, the business value part, and the proof that it is real. And we'll also try to take a look at how industry is converging to offer these sort of services, be it Azure, be it AWS, be it Google. Yeah, because the race for the capital expenditure was real a couple of years back, but now the trend is shifting because commodity will ultimately, these models will ultimately become commodity. Yeah. So with that, moving on to the next one, agent building. How many of you? Yeah, absolutely. Thank you. Okay. All right, that saves a lot of my energy. Cool. So how many of you have tried creating agents, already are creating agents in production? What's our separation in terms of the efforts that you're currently spending in building these different agents? How many of you, can I please see these hands? 1, 2, 3, 4. A few of you. So the question is, how many of you have tried creating agents or already using agents in production, in POCs, etc.? Okay, that's good. So building agents now is very easy. Now, if I want to make it even generalized, so building agents is not just about building agents. Building software in general has become very easy now. You just put these different commands to Cloud Code and go out, sip a cup of coffee, and then probably some of your modules are already written for you. Yeah, so that's not the hard part nowadays. What is required is where this actually creates a challenge when you try to move from these different POCs and then try to create a real solution for your business, put it in production. And it comes with its own set of challenges. Isolation. So what this isolation is, because say for example, we are building a chatbot, right? We would want to ensure that we are not mixing two user state. One user is not able to see the other user's data, and that's the bare minimum prerequisite that anyone would be expecting from the enterprise grade solution that you might be building. Second is the durable state. So again, steering away from the chatbot example. So it could be your business process that needs to run, but then run with certain context that is preserved for you. So the next set of actions that your AI agent or your workflow takes has enough context that is preserved from last state, and then it goes on to take those actions. Even after restarts, how it survives those catastrophic failures. So that becomes really important. The biggest one, folks working in the security space here would be able to relate. What has happened so far traditionally is we have been busy building all these agents, exploring these different frameworks like LangGraph, agent framework service, etc. People have started creating agents, but then these agents were always working in silo. Yeah, so maybe there is some team that is also building some agent interacting with your DevOps, or it could be interacting with your Jira. Your IT is unaware of that. That creates a problem for them, because these agents as an entities are sort of things that are doing something for you. They are taking certain actions. They are also using their own reasoning to take those actions, right? And you need to be in charge of that, because unless and until that is not happening, you are running a huge risk. If someone, you might be hearing these news different, right? So we have been hearing this for past couple of years. Some agent has deleted some critical production data of some organization. Why that happens is because you do not have such governance practices in place. This solves this problem. We'll talk about how Microsoft ecosystem is also helping doing this, identities and permission. When you create such entities like agents, they should have their own identities. So the tracking becomes easy. Who has taken this action? Who has performed certain action, and why it has performed certain action, right? So that becomes really crucial. The observability part that I was talking about, why it has taken certain actions. So you should be able to trace all these actions all the way back since the trigger was, since the trigger kicked in basically. And the scale. We all love building stuff. We are all software engineers, as we would want to call it, but then scaling becomes a problem, and that's the infrastructure, the platform problem. That's why the industry started shifting towards cloud to reduce their capital expenditures almost a decade back. And we are facing the same problems. Now, if you see all these issues, isolation, durable state, etc., there is no AI involved in there, right? So the real core software engineering that still exists here. Right? These are the classic traditional problems. Even if you recall, people have been working in this industry for a while now. You may recall that we have seen the similar pattern when we were exploring microservices almost a few years back, like 5-6 years back. It exactly had the same set of problems. So let's see how basically the new services that I was talking about, they help you address that. And at any given point, if you have any questions, just feel free to interrupt me and ask those questions, okay? Right. So because I think we have some of folks here who are present, they have not created their own agents so far. I'll quickly cover the basics, what an agent is. And again, this is one of the pattern that I see a lot more customers, people, students that I interact with. Everyone likes to talk about these jazzy terms, agentic engineering and agentic workflows. But then when we try to dig into the details of what agentic means, what do you understand by that? There are different versions of the answer that exist. And I know that none of them are wrong as such, but then the consolidated definition sometimes goes missing. So I'll first cover what agent is. So basically something that has a goal that gets triggered. It can perform certain actions for you. It is sort of borrowing its brain using large language models, small language model. Now, like I said, these models are now commodity. That means these models could be hosted in Databricks. Not sure how many of you know that Databricks also has started hosting OpenAI's models. So GPT-5 Plus series is now available there as well. Azure, of course, because that's the partnership started with Microsoft. That was the exclusive access to the GPT models Azure offered always. That has not been the case now because of the nature of the change in that partnership. AWS has that Bedrock, and it offers these models using that. So the point here is basically you are just leveraging or borrowing this brain as a commodity, plug it into your agent, let agent perform certain actions for you. And that's the last bit there, the act. So ACT could be then, as Manish was also explaining in this session earlier, I was listening, it was a fantastic talk. So he was explaining MCPs, right? So MCPs, what it does is it standardizes certain actions for you, correct? So because you need to look at it as a clay human, right? So wherein you need to stitch hands and legs into that, because then it should be able to then perform certain actions. How you do that, that becomes objective. Whether you do that using standardized layers like MCP, or you write your own custom code, call it as tools, plug those tools in so that agent takes that action. So that's basically an agent for you, okay? Something that reasons, understands, then performs an action for you. So that has been the trend shift in the industry, because we started off with creating these simple chatbots, correct? So you, like transactional relationship with these systems. You ask a question, it will either provide that answer directly with its knowledge base, or it may do some RAG so that it can go and find that answer grounded in your business context for you and then send it to you. But then now it's more than chatbots. So something that should be able to act as well is what is the least minimum expectation that industry has. And these actions, that is the part really is crucial now, because say for example, if you're creating a password reset agent for an organization, it does the job fantastic when you're developing that. You have productionized that agent. But then is it really doing the fine job when you put it in production with confidence? And it should be able to do that for like 10,000s of users in your organization. So that's why the standardization becomes really important. How many of you have worked with Microsoft Cloud, particularly while creating these agents? Are you aware of Microsoft Foundry? Okay, a few of you. We'll go through the interface as well. I'll probably cover the basics of it too. But then now this particular session, we are currently focusing on agents here. We are talking about it. What is Microsoft Foundry? I'll try to cover the basics of it as well. Like I said, models, the first one. Microsoft Foundry is the platform that allows you to create these different agents, test them, and also deploy them. Yeah. Now, why this is really important is Microsoft always has been the platform organization, correct? So it always has believed in creating different platforms for developers, so that developer community can come and build something together without having to know really the nitty-gritties of the underlying effort that usually it takes, correct? And Microsoft Foundry, that was the same sort of ideation initiative with which they started. What it does for you, it offers you different number of models, more than 12,000 models, I believe, that are currently sitting in the Foundry catalog. You are free to choose one. There are different billing and other aspects of that, but then to keep it simple, consider that you have plethora of models to choose from to plug it into your agent, right? Tools and knowledge. Again, it offers you that platform through which you can create these different data connectors, APIs, bring your own MCP servers, and then bring your own data as well to make your agents grounded in your proprietary knowledge. Yeah, the tacit knowledge that usually is locked with different people. And then the important part is agent. It allows you to create these different agents. Now, we'll cover in the next few slides what these different types of agents are, because not everyone, or it is important nowadays for citizen developers as well to be able to create such automation processes using AI. So at a times there is a preference that I shouldn't be needing to write the code every time to create that agent. I should be able to just get my stuff done and then also create it in a way that is already a production grade enterprise ready solution, correct? So we'll see that as well in action. So it allows you to create that too and then operate. This is the biggest hard part that I was talking about. This is where all your post development magic comes into picture to make it production ready. So that consists of your identity of the agent that we talked about, observability, evaluations, governance. Does anyone know what evaluations are in general in AI? Sorry, say that again.
How models or the agents are performing.
Correct. You're basically sort of trying to measure something, right? Because when you use these large language models, you may have heard this term called as hallucinations quite frequently, correct? What it means is hallucination is something that it just tries to come up with its own. Look at it as a sort of an alien mind or alien god, right? So it doesn't know, it doesn't think. All it is doing is just predicting the next token, next word in more general language, correct? But then we would want to ensure that it is really honoring your instructions that you are providing, that hey, you do not cross these limits, right? You're sort of drawing those Lakshman rekhas for these agents, yeah? So that's, but then how do you know that if it is really adhering to these different instructions that you are providing? The quality of the response is really up to the mark. How do you ensure that? This is where your different evaluations and evaluator frameworks comes into picture. So you can literally measure the accuracy in terms of the percentage, it could be the groundedness of the answer, it could be the fluency of the answer, it could be the coherence of the answer, etc., etc. Correct? These are only few. There are several other dimensions to that as well. I'll quickly cover that too when we actually run into the demo. Any questions so far? Cool, can move on. So like I was saying, this allows you to, this as in Microsoft Foundry, allows you to create agents. So when I say agents, there are two types of agents there in Microsoft ecosystem. One is your prompt-based agents. And this is that part wherein the code is not really required. All you do is you go and launch that Foundry interface. You put in your instructions. While you are creating that agent, you just upload your files maybe, or point that agent towards your SharePoint, which could be containing all these different organization files. You bring in different tools, like it should be able to do the web search as well. It's just a matter of switching that checkbox there. And then you have equipped the web search capability on your agent, correct? So that's all configuration driven. That's what we call it as a prompt based agent. We'll see that in the portal as well. And then this is something new. This is hosted agents. This is what we are taking a look at today. And this is really fun. People who have been writing softwares in industry for a while now has sort of created their own patterns, frameworks, inclination towards particular frameworks. And these this is the workforce that usually will try to prefer and create these coded agents. Why is because, any guesses? It offers you more control over your processes. You're not at the mercy of some interface that is allowing you to do certain things in a certain way, but then you just might want to have that flexibility that, okay, fine, I'll create my own tool definitions. I may have already created some API definitions. I just want to ensure that I give access to my agent to these APIs, and then I'll call them as tools for my agents, right? The intent here is the amount of flexibility it brings to the table, so that you still, okay, you are a developer, you focus on creating your code, you focus on creating your logic, rest will take care for you. Okay, you don't have to worry about all these different underlying fancy stuff that happens at the infrastructure and core services level. We'll see that towards the end as well when we enter into the demo. So what happens here is, like I was saying, your code, we run it for you. Okay, you build that using any framework. Any agent creation frameworks that anyone is aware of? LangChain is one, yes, that's good. Mistral.js, okay, anything else? LangGraph, has anyone heard of that? Okay. Agent framework of Microsoft, has anyone used it? There are a plethora of frameworks that has emerged in last couple of years, right? The foundation philosophy remains the same for all these different frameworks. It's just the preference that the community or your organization in terms of the skill set that it has towards choosing one, and the flexibility that it offers. Say for example, I'm running an organization. I have like 50 extremely excellent Python developers right? Naturally, I would probably prefer something that is really compatible well with Python, so that when I create these agent ecosystems, that becomes maintainable, manageable in long run, correct? So that's the sort of fundamental choosing difference. There are others as well. I'm just trying to oversimplify that right now, but then you get the idea. Basically, the principles remains the same across all these different frameworks. Now, the beauty here is you may have created these different agents using different languages. Foundry doesn't restrict you that, okay, fine, so you only build these agents using Microsoft agent framework that we own, that we created as a proprietary framework, that is open source, that's a separate thing. You can bring in any basically framework, and we'll see that how, because in the example that we are going to see, I have used a very simple agent SDK from OpenAI. OpenAI agent SDK code is running in Microsoft Foundry. How cool that would be, right? So we'll see that. Yeah, you build your own model, or you bring in your own model. So your model could be hosted in Databricks maybe, right? It is not even mandatory that you should only be connecting to the models that Foundry is hosting. So imagine this is where this is going. This is sort of offering you a platform. You bring your own ingredients and make that dish there, correct? So that's the sort of analogy that will be easy to connect with. No restrictions. You have better control over the CPU and memory state. That is very important. That's the capital expenditure part that I was talking about. Previously, hosting, I mean, let's not talk about agents and AI for a while, okay? Let's dive into the basics. Suppose that you are creating a web server today, or the API today. It will need web server like UVCon in Python. This is a Python implementation of web server. Now, for any sort of service to run, it needs that underlying compute, correct? And previously, even before the cloud era, people used to give this or procure these different servers, maintain them maybe under their table, right? The problem was the classic problem that everyone is aware of. Why we have shifted towards the cloud model is because we would want to save the capital expenditure there, because when you are not using these services, you are unnecessarily paying for those hardware components, right? So this is where we'll see that towards the end. When we'll talk about the billing, how it works and how beneficial this is for you. So the intent here is you get better control over the sort of memory that will be required for your agentic workflow, your agent, the memories, because there could be sometimes some memory hungry workflows. So you get to fine tune that. Maybe my agent 1 doesn't require this much of memory, my agent 2 only requires this much of compute, and that's how you're stitching your agentic experience together from the perspective of infrastructure. And like I was saying, that it's durable, long-running multi-step orchestration. That is also one of the benefit that you get, because the nature of the protocol is stateful in nature. By the way, a fundamental question again, what do we understand by the term protocol? Okay, set of instructions is one way to look at that.
Some primitives tied together with a state machine.
Sorry?
Some primitives tied together with a state machine.
Okay, that's also interesting.
Pre-decided instructions with some specific code.
Correct. I mean, if I have to oversimplify this again, protocol is just like, we are talking in English, right? So it's a sort of a communication that both parties understand. When we say stateful and stateless, if we go back in the era of web development, we always used to call that, okay, so REST is that stateless protocol. What do we mean by that?
Every request is anonymous.
Correct, exactly. So that your server doesn't have to have that onus of knowing your users, correct? You're basically just treating every request as a new request, and then it is onus on client to ensure that it is sending that auth cookie, etc., to the server every time. Same is the case here. It's stateful here in that case is because you would want to ensure that you are connecting to the right infrastructure nodes when your workflow executes, correct? So the onus will be to maintain and store those session IDs. We'll talk about session IDs, conversation IDs towards the end. I think that will become more clear. But then know that you are easily able to run these stateful long-running workflows using hosted agents, okay? Most of it, I think we covered already. Your code basically that you own, your logic, you as a developer gets to focus on that part. We package it as a container. Uh, don't get surprised when I start talking about containers, otherwise you'll be like, this guy will be now talking about containers, which is not even relevant for this session. It is optional basically. If you are someone who is pro in building containers, you love that Docker world, you're welcome here in this ecosystem as well. But then if you're like someone like me, I'll try to stay away from those Docker files and then run into troubleshooting something that is taking out much of my time and energy from actually building the core business logic, correct? So even that is fine. So you can just package your code as a zip, hand it over to Foundry service. It will take care of everything and deploying your agent as a hosted agent in the service. We'll see both options. For now, for the demo, I have still chosen to show the Docker-based approach. The Docker file is still there, but then it's very lean Docker file. And Foundry runs it. It gives you that endpoint so that when you host an agent, you can even, so say for example, agent 1, you deploy it as a hosted agent. That agent has its own invocable endpoint that you get as ready-made. And not only that, it also gets its own identity. Is anyone aware of Azure Active Directory? Active Directory for that matter, now it's called as Entra ID, thanks to Microsoft naming conventions every year. But yeah, so basically it's an entity for your agents that gets created, similar to users. Users are created as an entity in the Active Directory, right? So it's the same concept. Your agent also holds an entity. So that tracking becomes very easy for IT. So, and you get to do that granular permissions management, what this agent has access. So maybe my agent can be given access to SharePoint in read-only mode or role. So that becomes very easy. Yeah. So that's that. Now what I wanted to also show you is how this actually works. So if you take a look, this is where your code is you're going to bring in. And like I was saying, it could be written in MAF, Microsoft Agent Framework, LangGraph, OpenAI, Claude, SDK, and even your custom SDK if you have developed one. You package it as a container image, you push it in the Azure Container Registry. Now, this becomes crucial here. Does anyone know why we build these images? There is something called as registry, Docker registry. What lives there? Why this is even essential to have these images stored in registry sort of service?
It's one place wherein you can use them, so you can store them and the users can use those images as per their purpose. So that's a one-stop place we can say.
Correct. So it's a sort of a marketplace, one-stop shop where you can find these different images. Now we'll definitely not dive into the images and the layers of the Dockers, etc., etc. It's a separate topic altogether. But this, just know that you have some sort of baked-in images that are stored in that registry that you can pull and push at any given point, and then your infrastructure gets created using those images. Now in this case, that image registry is Azure, because we are dealing with Azure platform, that's Azure Container Registry. That's a natural service choice that becomes. Now this box that you see here, that's your managed environment. So Microsoft Managed Foundry Agent Service. So it's that managed environment for you where your agent will be running. You don't know where it is running. You don't have to worry about which compute node is hosting that. You don't have to worry about how it will scale and then how users will be connecting to that. All you care about is, hey, this is my code. Can you just take this code and run this as my hosted agent? And we are literally going to see that. And like I was saying earlier, so you get access to the Foundry models, you get access to the tools, all the goodness that basically Foundry as a service provides you, that platform provides you to interact with different services, bring or create your different tools, etc. Correct? Now this is at very high level. Now fundamentally, let's take a look at the understanding guide here. What this means is, now this is a sort of a onion that is peeled. Your code is running at the innermost layer. This is where that compute is. Okay, this is where your compute infrastructure is hosting that code that could be written in different languages and framework. This is that container registry or the container within which it will be running. Now what happens is anyone aware of adapter pattern? We used to have these design patterns back then that we always used to boast about. What is adapter pattern?
Again, a well-defined interface where you can plug it into other modules.
Correct, absolutely, you're right. So adapter is, take a look at these different sockets of the electricity around you. So we plug in some adapter and then maybe your devices are charged, or you get the electricity basically to turn them on. So this same interface. So that's what is happening here as well. So there has to be something that needs to exist so that your container request should be able to reach to the code that you are writing, right? And then when it responds, again something needs to exist that then transmits that response back to the container and then to the outside world. So it's a two-way handshake that usually happens through this adapter, and we'll talk about two configurations here that you get when you are creating or choosing this adapter, because it's all about now the protocol, right? How you're talking to your code, correct? So when it comes to protocol, like in layman's term, right now we are talking or conversing in English, but we could also converse in Hindi, right? So it's a protocol switch that could happen. So you get to make that choice here. What's that protocol you would want to select while you establish that communication? We'll see that in a bit. But then you get the general idea, what is placed where. You have code running inside your compute. Compute is your container. They literally, this is so new, folks, that they were using containers up till some point, right? The recent Microsoft Build event that I'm not sure how many of you may have followed, they have now changed that runtime to something else. It's a sort of a micro VM that they spin up behind the scene for you, and then where your code runs. It's something else. I'm not sure what it is called, but then it's really fast, lightning fast platform or the infrastructure compute that spins really quickly and brings your agent in action, or brings your agents live. So that's your container. Let's call it as container for now. And then all the goodness of the Foundry service. So that means models, guardrails, governance, monitoring, etc., etc. That all lives inside here, and the scaling, of course. Clear so far? Cool. Now what happens here is isolation and sessions. So if you recall the first few slides, we were talking about the classic problems that industry was dealing with even at the time of microservices evolution. First one was session. How do you ensure that your sessions are isolated between processes or users, right? So this is how it happens. So any new session that you connect to, the Foundry hosted agent will ensure that it is spinning that micro VM compute dedicated for that particular session. Separate session starts, it's a separate micro VM compute that will get created for you. One micro VM compute instance will be completely isolated to the other. So that means there is no chance, physically even, to mix up the data points or the data sets, assets, or even the compute resources. Yeah. So because my one session could be very memory intensive, my other session could be very compute intensive, correct? So that's how you achieve that. We'll see that, but then that's one of the biggest benefit. Now look at it as this way. So say for example, we see all these meeting rooms, right, around us. So if there is a discussion that we need to have, we'll probably go into the room, conduct that discussion. We'll probably be doing some whiteboarding as well. Now, we only needed that room for maybe say 10 minutes. We did some whiteboarding, we came out. When we came out, what this facility will do is they'll go into that room, they'll take a screenshot of that whiteboard. That means you're sort of saving that state. Next time, we might want to conduct that conversation again and extend that. Maybe after a coffee break, we go into the same room again, and they'll ensure that your whiteboard is restored for you, so that when you enter into it, you're not losing anything basically. So you get the idea. So I mean, the default idle session timeout is 15 minutes here. So you can still keep that session active for 15 minutes. If you move out after 15 minutes, that micro VM instance gets killed for you. Okay, and that's how the major cost saving happens. You are never paying for the entire compute resource 24/7. Correct. Next time your session begins, like I said, someone will restore that screenshot of the whiteboard there. So that means someone will ensure, when I say someone, and that's the beauty of the managed services. So there is always someone that you don't have to worry about. They'll do it for you. You just have to focus on your business knowledge and getting your processes fine-tuned, correct? So that happens. And that's how it's more effective for business, because it is helping you to achieve running your different workflows, agents, processes in a cost-effective way. Clear?
Describe this now is effectively function as a service, I guess.
Absolutely. Yeah, you can look at it that way as well. Right. Now, like I was saying, two ways of these protocols, right? Why this becomes really important is because now this is what you are choosing, how you would want to talk to the agent that is running within that compute. One is responses. This is the sort of protocol that is highly compatible with OpenAI responses model. Not sure how many of you have heard OpenAI has two models through which you can interact with their agents: chat completions and responses. This is a responses. Chat completion, that used to be the case in earlier days when you used to interact with OpenAI's models. Mostly it is responses now. So this is responses. It is highly compatible. That's the response contract that you get. So it becomes very easy to do that conversation seamlessly with OpenAI hosted models. If you are not comfortable with it, that's fine. You can bring in your own invocations. So the second type is invocations protocol. What that means is you're basically creating your own sort of contract wrapper. You bring in your own schema. You give that schema to your agent that you're comfortable with. It understands it. It responds back in that particular schema, and that's it. So you're kind of defining your own language. This is English. This is something else. If you look at it that way, correct? Right. So this is where the visual representation, I think that might help. So you're just basically bringing in your own different contracts, creating that as a bare junction box, and then that junction box is used and employed to run that communication between outside services and the agent. Correct? I'll quickly move on. What's the time? Okay. How many minutes do I still have? Okay, we'll quickly run again in the meantime. Right, like I was saying, this is covered one. We already talked about it. We pick any model, we pick any framework, and it just runs. Yeah. The next one is the BYO contract. So this is that contract now. Let's see this in action, because this is something that you will also see in the code. Now, what we are doing here is we are mapping the diagram that, if you recall, that we saw at high level, what runs where, into the actual more practical example. So this is that Foundry as an agent service. What you're seeing here is a special package that we need to import. This is a Pythonic implementation, so we'll mostly talk about Python for today. So what is happening here is basically you are importing this package. You're still within the Foundry space. You are implementing the responses protocol, so which is that compatible OpenAI responses protocol that I talked about. Foundry is providing you health probe and readiness probes to your micro VM that we were talking about. The streaming, SSE streaming lifecycle. What is SSE? Does anyone know? Server sent events, have you heard of that? When you want to basically proactively listen to something that server is sending to you. Usually it's all client server driven, right? So client requests something and then server responds. But then what if server wants to respond with something and then client should listen? So that's where you usually do the SSE. It is highly used in chat-based applications and listening to events that server want to send to clients to keep the clients warm. And then OTel. Has anyone heard about OTel, Open Telemetry? Okay, can anyone tell what is it? Correct. It's monitoring framework or the sort of standardization of the monitoring, the way you monitor your systems. Why this is important is because, as you can imagine, with the evolution of different cloud providers, different frameworks, different services, even proprietary services that developers might be spinning on its own. So people started to use these different frameworks to monitor their applications. So we were missing the standardization in that space heavily. Yeah, and that's why to bring that standardization, Open Telemetry is introduced. So it's, look at it this way, that the telemetry or the the metrics emitters of your applications and platform, they'll be probably producing that telemetry in a specific format. So it becomes easy for the consumption side to rely on the sort of telemetry that they'll be processing. So that's bring that standardization. So Foundry by default makes use of the Open Telemetry for this particular use case, hosted agents. This is that bit. So your code is running here. So I have deliberately created it using OpenAI Agents SDK because that's what we are going to see in the demo. But we'll see that in the actual code. We are using OpenAI Agent SDK. We are creating the agent using agent class. We are running that agent using runner. And we are using Azure Async OpenAI protocol to talk to the model. And we are using GPT 4.1 deployment. Okay. So you write that, you have packaged it. Now this is that response handler. That handshake happens between the Foundry and your code. This is where that responses model that we were talking about is a protocol that comes into action. Correct? So that's the contract between this bit and this bit. So that bidirectional handshake happens here. Just remember that. I think we'll take a look at it in the code. We'll talk about business value in a bit. So at this point, I should dive into a demo. I'll show you how this actually looks, what and how Foundry as a platform looks. All right. So this is your Foundry interface. This is the new interface that Microsoft has recently launched. As you can see, this is new Foundry. So this is a sort of platform that you get as a developer, that you can discover different models. As you can see, the plethora of models here that you get to choose from. So if I click on view all models, you get to see tons of models. It's a long list. You can even filter based on the industry, domain, features that you may want to select. Yeah. This is that build bit. This is where you are building your agents. Yeah. So if I say, for example, build an agent and give it some name, test 01. Now what happens is, you create that agent gets created as a prompt agent now. And this is that bit I was talking about. You are never writing the code. You see, this is that agent playground. I get to select my brain of the agent. I get to write instructions of my agent here. I get to equip it with tools. I get to, like the web search, I get to bring my own knowledge here by uploading files or connecting it to different knowledge sources that I may have within an organization, and then I get to immediately test it. This is that citizen developer sort of experience that even Foundry provides. But this is not of an interest for us today. What is interesting for us is something like this that I deployed last evening. So if you see, this is the same sort of interface, and that's the consistency of the platform. It allows you to test really quickly. Session is not started right now, but it will be the moment we send some message. But what is happening here is, look at this kind. This is hosted agent. From where I have deployed, I'll also walk you through the code. What is the response protocol it is using? It is responses, right? The guardrails part. If you recall the previous session that Manish was talking about, how you want to govern your agent with such guardrails. So you get to define that. And all these jazzy features, like you get to introduce the voice model as well and see. The biggest benefit here is, let's see, let me type. Yeah, we'll do that, we'll get there. So if you see, I have just messaged, and what it will happen is, now it will create that micro VM, because I think I have not tested this since last evening. So that means this is the first cold session that we'll go through. Here we go, it has responded. What's wrong with the resolution here? I think I need to collapse this, yeah. All right, so very simple request, tell me a smart joke. It has told you a joke because this is a very generalized agent. Now, the benefit here is, if you see this, all the telemetry right from your compute infrastructure is all baked in here. So what exactly has happened, you get to see that, right? And we have never written a code for this. So platform is taking care of that for you, okay? Similarly, this one, endpoint and IDs now. This is the agent. The agent is running. You get to even do the versioning. I'll come there. Remind me of version if I ever end up forgetting about it. This is that identity and access. So you have created an identity thumbprint of this agent in your Entra ID as a foundry. And this is the ID that your agent gets. You get to then use that ID to define these different perimeter based actions, like what it is allowed to do. When the trace your IT admin sees, it will be able to easily track then what was the ID that performs certain actions, etc. And this is that endpoint of the resources protocol. Now you can easily invoke that even using as simple as curl with right authentication and authorization with right keys. Traces, this is that hotel and the traces and monitoring that I was talking about. So if you see the beauty, you get to see everything that has happened in a conversation ID, that because you have managed to establish that conversation. So this is showing you the data of the last 7 days. So if I say, for example, open this one, you get to see that nice trace, what happened, what is the cycle, because this is agent also had to talk to the model that was again hosted by your foundry. So that means it has to obtain the token first to communicate with that. So all these entire stack trace that you get to see here. Developers will be really happy to see that, because you get to really closely watch the service, what exactly it is doing. Then the monitoring, this is the OTel part, open telemetry. This is where you will be able to see all your token usage. Again, platform is doing for you. Okay, we have never written a single line of code or configuration to do this. We'll dive into the VS Code as well to show you that. This is that evaluation part that I was talking about, that allows you to measure the accuracy of your agents. We'll not dive into that because it's a separate topic. You can create different evaluations, then associate with your agents, and then measure the quality of the response. And then this is something really new. You get to optimize how your agent is behaving, right? Sometimes you need to tweak your instructions of the agent, etc., etc. The biggest benefit that I wanted to show you is this. So as you continue to refine your agents, so you'll get to publish these different versions. You're never losing the track of the previous development that you deployed. And in agentic world, what usually happens is maybe there is a slight change in the instruction that I have done and then created as a separate version. And then now my accuracy maybe in my head is 98%. It is improved by 2%, say for example. Where is the data? How do you prove that, right? So this is where such features really comes in very handy, that you are comparing the versions side by side. On left side, you get to see what is happening with the UI here. But then on the left, you get to choose one version. On the right, you get to choose your previous version, and then also have the same chat interface. You get to talk to, and then measure that response. No, not this. Compare versions. Yeah, this is what I was talking about. So if I ask the same question to this agent, that is using my version 3 latest version, and then I get to choose the previous version as well, and then talk with the same question, and then see what sort of response difference that you get. Okay, so this is that platform features. These are the features that makes your life very easy without having to reinvent the wheel. Yeah, this is what I was talking about, the metrics. You see this, these are your evaluation metrics that you get by default. You get to see how agent is doing to adhere the task that you are asking, how it is resolving the intent that you are asking that questions with coherence, fluency, relevance that we talked about, whether it is producing responses that is self-harming. This is that guardrail that is going into the safety and privacy, right? So, but again, you are not writing anything. You are getting everything inbuilt, baked in for you. With that, I think let's quickly take a look at the code as well, because I know many of you might have been waiting for that. And this is open source, so I'll share the link of this repo as well that I have created. I'll zoom in a bit. Just a second. Anyway, this also works. So if you see this, we have this main file, okay? This is where we are doing all that initial plumbing, where is my model, I'm reading certain values from configurations, etc., etc. But if you see the namespaces here, we are creating agents using OpenAI chat completion model and OpenAI agent SDK. So if I see my environment file, not environment file, sorry, the requirements file, yeah, you see this package. I'm using OpenAI agents SDK. I'm using Azure Identity because we need to talk to those models. And then this is that special package that I was talking about that lets you define those contracts. So I'm creating an agent. This is a very simple definition. Where is the agent? This is the agent. Agent equal to agent. Name is assistant. Instruction is your friendly assistant, etc., etc. This is your model. This is your model name, and this is your OpenAI client. That's it. The beauty, the magic happens here. So this is where you're defining that adapter. Okay. It is doing nothing but then ensuring that it is doing that handshake using the response handler that you're writing. If you look at the definition of that handler, I'm just accepting the value from the user, from the context, which is hello. If no one says anything, then it's by default hello. And then I'm simply running my agent that I created using OpenAI agent SDK. That's it. And I'm simply sending that response back. So two-way handshake basically that is happening. This is running as an app, as a process. So that means that handshake binding always stays within that context. And then this, whenever this runs on that micro compute that we are talking about, it is always able to execute that code for you. That's it, nothing fancy here, very short code, very simple code to prove the point and the idea. This is where the agent.yaml is. You get to define in a declarative way that, okay, what is the protocol that I want to use? What is the kind that this agent will be using? If I want to tag my agents with something and inject those environment variables that may contain some sensitive information, right? Azure.yaml is more of an Azure configuration that you get to define in terms of the infrastructure. This is that control part that I was talking about. I'm choosing my CPU and memory requirements for this micro VM. So whenever a new session starts, I get to define that. And this is all AZD based. So deployment is very easy. There are predefined commands that Microsoft anyways has released. They call it Azure Developer Tools, AZD, as a CLI. You just need to log into AZD, point it to your Azure subscription, and just run the command AZD up or deploy. It will take care of deploying your infrastructure resources, all these different artifacts using bicep templates, which is infrastructure as code, and also deploy this agent. And this is that part that I was talking about. So the Docker file that you see here, that is optional. If you want more control on your infrastructure, recommended that you go with this option. Someone who is not very familiar or comfortable creating, maintaining these different Docker files, that's fine. So there is a separate command that you get to run. So it's all documented in the deployment.md that you will find anyways in the repository. But you just hand over that, hey, this is my code. You package that as zip. If you want to create a Docker image out of it, you do that. I am not comfortable doing that. So this is the outsourcing that you are doing to the Foundry service. That is doing it for you. Okay. And the infra part that I was talking about. So that's all in here. So this is infrastructure as code that resides here that actually is creating these resources for you. So when I see these resources, these are those resources. So if I go to Azure portal, these are the resources that it has created for you. Okay. So this is that Foundry as a service and the project. Open telemetry that I was talking about, that basically uses application insights that is backed by your log analytics workspace, and the container registry, because we need to push that image somewhere. So this is that resource it creates for you. Okay, that's the lean setup that you get to do. When I launch this Foundry project, you simply land here and then you have your agent running in this interface. You get to fine tune that, you get to refine that, you get to productionize that by applying those different guardrails, etc. So that's mostly it. I know that if we dive into each of the aspect of the line that we just saw in the code, that will be too much, but maybe feel free to reach out to me if you are interested. I'm happy to have a separate chat about that as well. Before I move on from demo to the slides again, any question that anyone has? Yeah.
You mentioned the CPU memory as a static parameter.
Yeah.
So how the scaling will work?
This is to begin with, right? So
That is a beginning parameter.
yeah, correct. So if your user load increases, then it's the platform responsibility. Yeah, how it scales, and then you don't have to worry whether it is scaling that vertically or even horizontally. Even if it is scaling horizontally, then you don't have to worry about putting that load balancer in front of those different horizontally scaled instances and then allow that traffic. Yeah, cool.
Again, I question, when you're working with a micro VM, do you really care about scalability? Because like shoot and done.
Yeah, exactly. So I mean, that's the beauty, right? So you're outsourcing that to platform. We don't care whether platform is using micro VMs or some other compute infrastructure behind it. All we care is, this is my initial compute, that bare minimum that I would want to sustainably run my agent and processes. That's it. When it scales using that configuration.
So does it mean that agent framework does not always use a micro VM? Is that wrong?
That I will not be very sure about that, because agent framework, so you're referring to MAF, I believe, right? Microsoft Agent Framework. Microsoft Agent Framework is that library that lets you create these different agents. Not necessarily you will be hosting those agents in Foundry as a framework. You may host them on your own compute infrastructure in the container apps maybe, or even a virtual machine, Linux. Yeah.
So Foundry will apply charge because this is the platform.
Yes, absolutely. And good question, because this is the cost aspect that we never touched. So you are paying for compute, you are paying for tokens usage. And this is all in preview. So not really recommended to begin writing applications for production. But then this is more in an exploration phase right now. There will be certain tweaks and things that will be changed over the period till it hits the GA. But your two factors that are contributing to the cost.
One is the Microsoft Foundry.
Microsoft Foundry, if you are using model hosted somewhere there in the Foundry ecosystem, and the compute part for the duration to which you are using that. So like I said, 15 minutes of idle time. If you have only used for 10 minutes, then you are paying only for 10 minutes of compute. Rest of the time, anyways, your container or the micro VM was destroyed. So there is nothing to pay.
That like anyways that infrastructure will be paid per use, right?
Correct, exactly. Yeah.
For platform it might be a static.
No. Platform is free for you. So Foundry is a platform that comes in free. Yeah. Any question? We are on time? Okay, I'll just wrap using last 5 minutes. I will rather okay. Okay, so we were here, we saw that. This is the business value, and this is the interesting part. No matter which vertical that you belong to in the organization, even today, so engineering leaders and product managers will really be interested to see how fast you can take your applications to production. This service answers that too. If you belong to the security and risk domain, you have your answers because you are governing by default. That's the first choice, because you are creating all these different identities and then creating these different isolations of the worker processes. If you belong to architects and CTO offices, this is again offering you that flexibility because you are never locked in with any of the provider or the vendor. And if you belong to the finance and budget, something that we really want, and this is where the shift in the industry that we are seeing, that anyone would want to offer services, but then at very cost effective way. The AI game is not that cost effective in general, but the aspiration is to offer services that are really cost effective. This is what, and the part that we just discussed, right? So you're only paying for the part that you're consuming for. You're never over provisioning your resources. So that's the sort of the business value that it brings to the table for everyone in the organization. Now what this means is, okay, we're back. So what this means is there no future for prompt agents? No, that is not the case. I'm not sure why it is going off. Thank you. All right. So this is that decision metrics and the model that you can follow. So when to use what? If you are really familiar, if you really want deeper control of your processes and agents and services, then you reach to the hosted model, and all the beauty of the platform that you get, all the richness of the Foundry as a service that you get baked in. If your job is to really quickly validate something, test out the feasibility of the technology, and whether something that can be really solved using it, then go for the prompt based agent. It's very, very effective and efficient for prototyping. But when it comes to creating those complex business workflows and processes, this is where I think the developers community will still try to choose something that they own, that they can extend easily, and then they have better control over. So that's that. And this is the point that I wanted to quickly make. This is where the industry is converging, right? This is not something that is a gimmicky feature that has been launched. Everyone is trying to do the same thing, because we have seen this shift always from your early cloud days as well. Bedrock Agent Core is doing the same thing, Google Agent Engine is doing the same thing, and the same is being now offered by Microsoft hosted agents, okay? Because we are moving towards the era where we would want to run those AI processes very efficiently and in a cost effective way with responsibly. That's that. I don't think that this adds any value, but then this is all to highlight the beauty of the platform that it can do for you, the agent optimizer and all that we quickly saw. Right, like I was saying, this is all in preview currently, so you always go and check before you start building what is the current status. It is currently available only in limited set of regions, and the cost model is this right now. Okay, but then it may change. And the permissions, you'll need certain permissions in your Foundry resource that you need to run a check with your IT and ensure that you're equipped with these permissions to even experiment. With that, I think I'll also upload this deck in the repo, so you get access to it. All these links are there. So this is my demo that we just saw today. I have kept it open source in my repository. There are hands-on labs as well. If you want, you can go ahead and do that. There is a Foundry sample that you can run to deploy your first hosted agent, and then this is the quick start guide. That's my LinkedIn QR. If you want to connect with me later, happy to do that. If you want to have a quick chat, happy to do that. With that, I think I'll conclude. There will be a note, there will be a session feedback that will be added towards the last slide in the next session. So it will be great if you can provide us the feedback in terms of whether this was a value add for all of you, etc., etc. You will see those questions there. Yeah. All right. So with that, I think I'll conclude, and yeah, thank you once again.